Anybody? Nothing? Oh, let me say this. Uh, did everybody get my email reminding you there are specific homework problems I have assigned? Let me show you. There have been several people that have emailed me and that have turned in so much homework. I'm like, what? And they're like, I don't know how I'm going to keep up. And I'm like, I don't know how you keep up either if you do every damn homework problem. I didn't assign you everything. I do have one question in chat, but let me do this real quick. It's a private chat, by the way, so you can't see it. Let's see. Right here. Kablamo. Kablamo. Right? Right? I know I showed this page. I know I did. It's right here. Look. Homework timeline. Right there. It's crazy. And again, what does E30 mean right there? Like E30, what does that mean?
Every third one.
Yeah, freaking every third one. This is right up here, right? Right up there. So please do God. Now, if you want to, you could do every single problem if you want to. That's beautiful extra practice. I'm never going to stop you.
Oh.
Everybody good out there?
Wait, were people actually doing
Yes.
every
Yes.
of the 54 things?
Yes.
The 65. I
Yes.
respect that, but too far.
Respect it? I don't know if I respect it unless it was chosen.
If they have the drive to do that, that's respectable.
It's not the
Still too
drive.
far.
As they're doing it, they are cursing my name. Damn you, Jeff. 47. It's like, exactly. I know. You don't have to call yourself out. Don't call yourself out. And you're not alone. It wasn't just anybody. It was several people. So it's all good. I didn't make a big enough deal out of it, and that's my fault. I know I showed it, but maybe I didn't make a big enough deal out of it. Whatever. So that's a little gift to you if you thought that you were supposed to do all of them. The same thing as if you forgot Friday and Monday are holidays. So if you, like me, I forgot that, and all of a sudden I got a nice gift of a 4-day weekend coming. Even though I gave you a big ass weekend last week too. Anyway, any questions? No questions? I've been trying to, oh, I got one question. Hold on. I'll come back to it. I almost cried doing the assigned amount. Are y'all okay? All right, Chloe, all right.
I was talking about the homework.
No, I know. All right, if you know exactly the homework I've assigned, right? And that still feels like, all right, let me say this. I don't think I've said this yet. I don't think I've had the talk with you yet about homework, by the way. Have I? Stop me if I've already said this to everybody. If you do not have time to do every single homework question I've assigned, don't do every single homework question I've assigned. I'm still going to be finish this. I'm not going to give you full credit. Everybody with me? What's the most heaviest weighted things in this class?
The exams.
The exams. How do you prepare for exams?
Studying.
And what's the biggest component of studying?
Homework.
Time.
Homework, right? So listen, if you are behind and you're like, we're going to have a test through 2.8 and you are in section 2.3 or something, you with me? Start doing every other problem that I assigned or something, right? You don't want to take a test and have entire sections that you haven't done anything from. Does that make sense? Am I saying that you don't have to do all the homework and everything's great? Is that what I'm saying right now? No. I am saying homework does not count anywhere near as much as exams do. So you need to make sure to do enough homework out of all the sections so you're ready for the exam. Yes? Yes. Okay. So, all right. Okay. I really hope all that makes sense. So the test, when's the test, everybody?
Next Friday?
Yeah, how do you know such an important date? Sorry, I'm just going to be passive aggressive or whatever, facetious here. Right there. Oh my shit. Look at this sheet. It tells you the homework, tells you all the, I know I'm being a dork right now, but too bad. It tells you all the dates of things are going to happen. It's amazing. It's almost like you know exactly what's happening the whole damn semester. It's crazy. Sorry, I don't mean that to come off as condescending or anything. Holy shit. Holy shit. It's almost like I want you to know what's going on. All right. Sorry. I'm in a rare mood today, I think. Okay, so if there's no questions from homework, we're going to get right into finishing up chapter 2. And first thing I want to do, I think, is let's see. Yeah, let's do this. Okay, I got you. Am I gonna be lazy today? I think I am. Everybody see the whiteboard there? Okay. So we have a procedure. Maybe I shouldn't be lazy. Screw it, I'm gonna continue. To find the slope, so if I'm given a function f of x, what procedure do we use to find the slope at x equal a? We got 2 ways to do it, right? So I'm gonna write one of them down here. So what's the symbol that we use? What symbol do we use to denote the slope of a function at a point, at a location, at an x value?
F prime.
F prime, I like it. So the slope, we denote it with f prime. And one way to do this, let me do the second way first, because it's the more generally accepted way to do things. It's just this guy here, Jeff. Okay. Now, this is going to be a weird question right now, but can somebody tell me f prime of 2 or something like that? What kind of thing is that? F prime of 2. Is it a function? What is f prime of 2? Is it a function? Is it an equation? What is f prime of 2? What could an answer to f prime of 2 be? This is really weird, I know, but what does f prime of 2 mean? Let's start there. Oh shit, what has happened to what are you doing? Sorry, hold on. I love my stupid little pen is all freaky. What would f prime of 2 mean? What does that mean?
The slope of the function at 2.
Beautiful. The slope of a function at 2. I like it. And the only thing that could be is a number. Is everybody cool with that? F prime of 2 or g prime of 7 or h prime of negative 11, they're all numbers, correct? They're numbers. They're numbers that represent the slope of right there at that point. So really, if you want to get really into it, it means the slope of the tangent line to f of x at x equals 2, right? So it's kind of like if I was swinging something and I let go, it's the direction it would fly at that instant, because it would just continue along the tangent line at its trajectory. Come on, brain. Okay, how's everybody doing so far? So this is all stuff we've talked about. The other way to do it, which is not done quite as much, can I fit it over here? Can you draw, Jeff? All right. The other way to do it was, screw it, Jeff. Let's write it all. Clear it. Oh, Jesus, I didn't ask you if you got all that. I'm sorry, everybody. So f prime of a, the other way to do it would have been the limit as x goes to a of f of x minus f of a over x minus a. And the nice thing with this form is you can see y2 minus y1 over x2 minus x1. You can actually kind of see it. But all of it is built on slope. It's just built on the slope formula. And somebody earlier pointed out that it's just algebra. And yeah, if we slap this thing on to the slope formula from algebra, suddenly that's calculus. So calculus is just the next natural step. That's all it really is. And you guys, as you're doing the homework, you're like, I don't know, Jeff. I think it's more than that, but it is more, but not yet. Okay, so let's do a specific example. So let me give you, so let's say that, let me do this really, let's do this up. let's say that this is the position function. And this is the actual position function. If you drop something, this 4.9 is actually related to the gravitational pull. Do you have to know that to do the math? No. But just to let you know, this is a real equation. So if I drop something, the 4.9 is related to the gravitational pull. Is everybody cool with that? All right. All right. And again, it doesn't really matter when you're doing the math. So this is the position function. Very often we use the letter S for position because we're weird. And X is time. Okay. So what if I wanted to know the velocity after or at, let's say, 2 seconds? How would I figure that out? What would I do? How does velocity relate to position? Let's say this is seconds and the position is in meters. Come on, guys, come on. How does velocity relate to position? Give me a velocity you've traveled at recently in a car. Just give me any velocity. Give it to me.
50 miles per hour.
50 miles per hour. What does that mean?
It determines like how fast I'm going, like
Sure.
certain rate of speed. I guess.
So it pretty much traveled 50 miles per the hour.
So every hour you would tack on another 50 miles to your position. So
Yes.
does it describe how your position is changing
Over time.
over time?
Yes.
Everybody with me? So isn't it a rate of change of position? Velocity is a rate of change of position. Does that make sense?
Yes.
Okay. And again, we're not in physics class, but this is kind of stuff we should just know. And what does the slope tell you about a function?
I'll change over time.
Yeah, slope is a rate of change, right? And velocity is a rate of change of position. So how do I interpret this question then in the appropriate symbols? Please stay with me. It's okay if you don't know the answer. Let me know if you know it. How would I represent this question in just symbols? Oh, I got a chat that I missed. I'm sorry. I can't. Carmen, you're good. We could do this. We could do this. Remember earlier I said if I have a function f of x, how did we showcase the slope at x equals a? What was the symbols for the slope at x equals a? What did we use for that? What symbol did we use? What little thing did we put on the f?
Prime.
F prime. So this is the slope at x equals a. So what do we really want to know here? The rate of change of position. So we want to know the slope at x equals 2. Slope of what?
Velocity.
Sorry, go ahead.
Oh, I was gonna say what you just said. Velocity.
No, because I don't know what the velocity is.
Oh.
What is the velocity? So what I was about to say is velocity is a rate of change of position. So if I want to know the slope, which is the rate of change at x equals 2, I want to know the s prime at 2. Prime is slope. Prime is rate of change. So what does this really say? The rate of change of the position after 2 seconds. Is everybody with me? We have to know how to say the symbols, but more importantly, what the hell the symbols represent. Okay. So how are we going to do this? So I want to use the limit as h goes to 0. Let's see if you guys are all cool with this. I've got an s now instead of an f, right? So it'd be s of 2 plus h minus s of 2 over h. Is that all right, everybody? You guys with me? F of a plus h minus f of a over h. That's exactly what we're doing. Okay, Carmen's with me. Okay. And now it's just plug and chug. Now it's just plug and chug. Why is it approaching 0 and not 2? Oh, okay. All right. This is a good question. What is approaching 0 and what does that mean? What does the letter H mean in this case? You're all like,
Input value?
say again?
The input values?
No, it's related to the input value. So let me remind you guys. So we want to know, so we got this S, it looks something like this, right? It's parabolic, and we want to know at 2 what the slope is. So what do? We go to 2 plus h. We go h away from 2, right? Everybody remember this? How do I find the slope? How many points do I need to figure out the slope?
2.
2. Calculus, funky ass calculus, says, I want to know the slope at 1 point. And we're like, calculus? What? What? Because we need 2 points. Yes, is everybody? That's the fundamental problem calculus addresses. We want to know the slope at a point. We should be able to figure that out because at every point, I am moving at a certain speed. So there is a slope at every point. But the only way to figure out the slope, I need 2 points. Yes, does everybody get that? So how do I take care of that? There are 2 main ways, and this is the main way we do it. We go a little bit away from the point we want, and we figure out the slope. Oh, shit and a half. We figure out the slope through that line there. And how do we improve that? We let the distance away from 2 shrink, right? So we get step closer and closer. So what is the issue? Can I find the slope at 1 point? No. So what's the best we could do? Take another point in that point and just get closer and closer because I can't get it at that point. Isn't that exactly what limits were built for? I really want you guys with me on this, obviously, because this is the underpinning of everything we're doing. So in this formulation, H is how far away that second point is from the 1 point I'm interested in. So what am I going to do? I'm going to let that other point get freaking close as shit to that one. Okay. And by this stage of the game, we have evolved past tables, right? I'm not saying you're not going to have to use tables on the quiz or on the test. And by the way, remember there's a quiz today, but we'll talk about that in a minute. There are going to be problems. You have to use tables. But at this stage, 2728, we are past tables. We're past them. We know the algebra of limits now. So let me see. How do I want to do this? Oh, let me just keep going here. You can do it, Jeff. There you go, buddy. Okay. So is anybody not cool with how this was set up? Right here. This is just using the definition of derivative, right? Which was the f of a plus h minus f of a over h, the limit as h goes to 0 that. Okay. So what is s of 2 plus h?
4.9 times 2 plus h squared.
Yeah, 4.9 times 2 plus h squared. Let's clean that up a little bit up here. So it'll be 4.9 times 4 plus 4h plus h squared. Is that cool? I love you guys. Are you guys not okay with that? What's happening? Can you see it? Is my screen weird? Is everybody all right out there? What's happening? I got a chat coming at me. Where do we get 4.9? It's here. Remember, this is the function here. Yeah, that's all. That's all. So what's s of 3? 4.9 times 3 squared, right? That is just the function that we're working with. Okay. Okay. So somebody help me out. 4.9 times 4. Let me see if I could do that in my head. Is it 19.6?
Yeah.
plus 19.6h plus 4.9h squared. All right, now listen. I really want you guys with me. All right. Nobody said they had a problem with what I wrote here. Nobody said they had a problem with what I wrote here. You write that down. And then you say, oh, I got to figure out what the shit that is. So look what I did. I went and I figured out what the shit that was. And now I can take this and plug it there, right? I love that approach. It's called a construction approach. You go somewhere, you construct what you need, and then you bring it back and you plop it in place, right? So I've got on the top, I've got 19.6 plus 19.6h plus 4.9h squared. And what's S of 2?
4.9 times 2 squared.
Yes. And what is that?
19.6. Negative
19.6.
19.6.
Yeah, dude. And of course, all right, let me stop. You got to let me know the minute you don't understand what happened. Is everybody cool with what is happening right now? Okay. Angel, go ahead. What's up?
I was just gonna ask like how the 19.6 got caught, but I think I kind of understand now.
How it got caught?
Yeah, like how you got it.
Oh, I see. Because yeah, this S of 2 would be just plugging a 2 in, right? Because 2 squared is 4. Yeah. So now these cancel, right? Bam, bam. Yes? And then I could cancel. Can everybody still see this? I'm way at the bottom here. All right. Nobody's saying they can't. And then can't I kill an H here and here? One of the H's cancel. So I get 19.6 plus 4.9h. And what is that limit? As h goes to 0, what happens here? What happens to this guy? As h goes to 0, what happens to this?
Becomes 0.
Becomes 0. What happens to 19.6? Does it care what h is doing?
No.
No, it's always 9. So the answer is 19.6. Now, here's the tricky part. What are the units?
Meters per second.
Yes, because its velocity will be change in position per time. So the position is meters and the time is seconds. So 19.6 meters per second. For Americans, we're like, what is miles per hour? I don't know. Right. Too bad. Too bad for you. All right. Hopefully you followed along as we did that, because if you just look at this right now, this is a lot of like, what the shit, right? So hopefully you followed along as we did this. Okay. I'm going to clear this. It's going to go away. Okay. It's going away. It's going away. Bye stuff. Okay. So what about, all right. So what if I had, why can't you get that out of your head, Jeff? It doesn't matter. What if I had tomatoes picked as a function of number of people picking tomatoes? Everybody with me? Tomatoes picked as a function of number of people. It makes sense that the more people that come, the more tomatoes I can pick. Yes? The more tomatoes that can be picked. What would this mean?
Every
When
seven
there's 7
people.
people, 10 tomatoes get picked.
Yeah, well, we got to be careful. Okay, let me do this. What would this mean here by itself? What would this mean? What would that mean? How many people are picking tomatoes?
7, and they picked 50 tomatoes.
Pick 50 tomatoes. Stay with me. This is neat. Everybody with that? Everybody see that? Now, this question is a question, a next level question, right? So this is very freaky. I really want this to make sense. But this is, remind me, what does this symbol right there represent?
The slope.
The slope, good, or rate of change, right? Oh, look at this. Ricardo, are you a business person? I love it. Because they talk about marginal cost and marginal profit and all that kind of stuff. I like it. Do you know what marginal means? Does it mean something that you've put butter on? No. Sorry.
Does it mean like the rate of change from like the thing before?
Yeah, so all right. What this means is when there are 7 people picking tomatoes, if I added more people, I could get 10 more tomatoes picked in a day or whatever it is. So what this means is this would be the rate. So this would, what units would be on 10? This would be 10 tomatoes per person, per number of people. So what this means is I could get 10 more tomatoes if I add another person into the mix. So this would be, I got a better example on a worksheet. What I was really focused on here was the units. But what this tells me is, should I add more people then? Yes, because if I add another person, I can pick more tomatoes, right? I don't know if you guys are really with me. Let's do this. I might as well just go straight to my worksheet. That might be the best thing. I'm going to stop sharing this. Okay. So let me, if you're in Canvas, let me show you where this is. If you're in Canvas, oh shit, nah, there we go. What time is it? Time flies. I've changed things around. I've kind of moved things around. Let me become a student so you don't see too much. Dooby-dooby-doo. So there's a new thing right here. Section 2728 worksheet. All right, so pull that up. And if you can't access Canvas, just watch me. We'll do this. So let me, somebody see where that is if you want to pull that up. All right, I'm going to stop sharing and I'm going to share this in a better way for me. Where'd you go? There you are. Okay. Bam. All right. In the interest of time, I think we'll sort of do this together. I'm going to let you guys think about a question, then we'll do it together. Number 2 is going to be sort of like the tomato one, just better. But let's look at number 1 real quick. What does this symbol, what does this here mean? This first thing. F prime and -7. What does that represent?
Gonna change when it's at -7.
Yeah, and we can be a little more algebraic in our discussion now. It's just the slope, right? I've got a graph, and this is not a question about like physical so I can see there. It's just the slope of the function at -7. Can anybody tell me anything about the slope of the function at -7? What is true about it?
It's
Negative.
negative.
Totally, right? How do you do this, Jeff? I don't know anymore. Okay, that'll work. Is that going to work? Oh, geez, that is weird looking. That is weird looking. Oh, my. Hold on. Oh, that's right, Jeff. Don't worry about that. That's fine. Hold on. I'm sorry, guys. Give me a second. Bum, 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 bum. Bum, bum, bum. I don't know. All right, screw it. Do. Sorry. Okay, there we go. So I want to know the slope here and the tangent line, crap and a half. There's no way in hell I'm going to do this. The tangent, there's literally zero way I'm going to do it. Okay, hold on, guys. Let me use a different way. Bum, 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 bum. It's so fun watching an old man with stuff. Okay, here we go. Let me see if that works better. A little bit. Okay. So obviously that tangent line is negative slope there, right? So this is kind of bigger negative. What about this guy? Somebody else who hasn't told me anything yet. Don't make me call people out. I don't like doing that. What is F prime? What can you tell me about F prime at 1? Any?
The
Who's
slope
out?
is also negative.
It's also negative. Is it as big negative? Is it bigger or less negative than the one at -7?
It's less negative. It's more gradual.
It's less negative, right? So if I try to draw in everybody, oh, Jeff, that's not terrible, Jeff. You almost got it. It's definitely less negative, right? Does everybody agree with me? It's definitely getting, okay. What about, so this is less negative. What about f prime of 2?
Positive.
So what do you guys think? Right at 2. What do you think's happening right? Oh, Jeebus, Jeff. It is so hard to draw a straight line on this thing. Looks like 2 is just crying. Okay, stop. All right, let's see what I can do here.
Someone said it's getting positive.
What is it right at 2? What is it doing right at 2?
It's the slope is 0 because
0!
it's
Sorry, I don't mean to yell it.
it's stopping and then going in another direction.
Yes.
That makes sense.
Yes. If it's negative and on the other side of it is positive, what's it got to be right in the middle? 0. And you can kind of argue that it looks like it's not really zeroed out, but that's basically, it should be like right near 0. Everybody see that? So this guy looks basically to be about 0. Flat. It's a flat slope. What about at 3? Somebody else who hasn't said anything yet. What can you tell me about 3? Oh, I got a chat. Is that from earlier? Slope is, okay, sorry, Ricardo. That was from earlier, I guess. What about at 3 here? What's true about the slope there? If you were on a roller coaster, would you be going up, down, or straight? At
Up.
3. Slope is positive. I love it. So I think I didn't even realize this when I put this together. I say arrange the following numbers. Aren't they already arranged, right? Big negative, less negative, 0, positive. So they're already in order. Do you guys see how to look at this? Okay, the prime notation means slope. So in any question, I can look at it as slope if I need to. Certain problems, I can look at it as, you can do it, Jeff, rate of change if I need to, because that's what it is also. That's what slope is. Okay, now the bad part about doing this, Jeff, is you can't keep all that. That's too bad. I'm going to clear all this away. Okay, let's try to do it this way. I'm going to try this again. All right, now read through this, number 2. Read through this, number 2. Okay. This is going to be a little bit funky. It's just the way things are. It's hard to come up with a really great example. But, so what does P of A mean by itself? What does P of A mean again? Anybody?
The amount of money per car sale.
No.
Oh, wait, no.
What does P mean? What does P mean?
Car sale profits.
Yeah, the profits you'll make. So what this means is, and A, of course, is the advertising expenditure. So if you spend thousands of dollars on advertising, you will expect to make P thousands of dollars in profit, right? So if I said, you can do it, Jeff. So if I said P of 10 is 5, if we spend $10,000 in advertising, let me make this 50 so it makes more sense. If we spend $10,000 in advertising, we expect to make $50,000 profit. That's what that would be. Yes? Everybody? Okay. Everybody really with me? Okay. So this is a little bit weird. Let's see if you guys can do this. P prime of A. What does that mean? Well,
It's like if you like spend or if you like sell another car, the amount of profit you'll make at like that specific car you're selling.
not quite, because neither of the variables are number of cars. Yes?
All right, sorry, advertising. Like if you spend another dollar in advertising, the amount of profit you're gonna get at that.
I like it. So it's the rate of change of profit with respect to advertising change. So if I increase my advertising a little bit, this tells me if the profit's going to go up or down and stay the same. So what if P prime of A was positive, right? Should I, what does that mean?
Means that well, if you put more money in advertising, your profits slope is going up.
You should make more profit then, right? That's what that
Mhm.
means. Now, listen, everybody. This is really key. If I have a function and I am like here, isn't that a positive slope? Yes?
Yes.
So what if I increase the amount of advertising to here? Am I making more money?
No.
I'm making less money now, right? So I really want this to make sense. The slope for a curve isn't ever constant, or very rarely would be constant, right? So if you take too big of a step, you could go to the others. You could be losing money. So you got to be really careful. So what does this mean? Don't say anything. Try to write down in words what that means. And you can pick it apart, right? What does the 500 mean? Right? What does the prime mean? So what's the 20 mean? You can do it. I know you can do it. All right. Who thinks they've got what this means? What does the 500 mean? Let's start there. That's the easy one.
That's the advertising expenditure value.
I like it. So that's if we are currently, oh my God, Jeff. Spending 500K on advertising, right? Let me say instead of if, let's say given. Given we are currently spending $500,000 on advertising, we can expect to make how much more?
A change in profit of plus $20,000.
Yeah. So if we can expect to make 20,000 more in profit for every 1,000 more we spend in advertising, right? So if we increase the advertising by one step, which is 1,000, we predict we'd make about 20,000 more. Now, remember what I said up here. The minute you are away from 500, the minute you go to 501 or 502, isn't the slope going to change? And we don't know what it's going to be until we get there, right? So that's why the next question, I really hope you guys are with me. The next question is really important. Suppose they plan to spend about 500,000 and they calculate that, like somebody said earlier, this is called marginal profit. We're not a business class, thank God, because I hate business. But if we calculate that the expected rate of change of profit is 20,000 from where we are now, should the company spend slightly more or slightly less?
Slightly more.
Of course, they should spend slightly more because the slope is telling me my profit will go up if I spend a little more. You don't want to spend too much more because then you might go on the other side of the hill, right? Does that make any sense? If you take too big of a step, you don't know what the slope is doing now. You could actually go down on the other side. You don't know. So business is just a bunch of recalculating equations and changing the price point and then recalculating everything again. Where are we now? And then changing stuff. And then it's insane. It's insane. It's insane. Sorry. Did that make any sense? I mean, no? Are you guys okay? You guys are roughly okay? It's a little bit weird.
Can
Okay.
I ask like an if question?
Certainly.
If like P at 500 was closer to 0, would we want to go down in advertising?
I like it. So I love it. So part E, if P prime of 500 was 0, what does that mean?
No profits.
No. Careful. No, it does not mean that. P prime is not profit. It's the change in profit. So if P prime of 500 is 0, what could that mean?
There is no change in profit. You're making the exact same whether you spend 500K or not.
So if the profit function looked like this, where would we be on this function?
On the top of in the middle of the curve where it's
And
just
isn't
flattened
that
out.
the holy spot? Isn't that the place a business wants to be? 'Cause
Hallelujah.
that's the maximal profit, yes? But I love you guys. But couldn't I also be there?
Yes.
OSMAC. So of course I just got to pay attention to what's going to kind of, I know if we change the advertising, I know if I'm climbing up or going down, correct? So I have to kind of pay attention. And if P prime is 0, that's like, we're good for a moment, everybody. Let's just not change anything. And then we'll reevaluate later. All right. So what if P prime is negative? So in this case, we don't change anything, correct? We just keep going the way we are. We're in a good spot as long as I know that I'm not on the downswing. Obviously, we don't want to be in a downswing. What if P prime of 500 was negative something? Where am I at on this graph here? What side of the hilltop?
One that's heading downwards on the right.
Yeah, I'm on this side. So
Yes.
now should I spend slightly more or slightly less on advertising?
Slightly less.
Slightly less. Exactly. There's a sweet spot. Does that make sense? If I spend too much, then I'm not selling enough to make up for how much I'm spending. If I spend too little, then not enough people are hearing about us and whatever. Does that make sense? Which is a huge reason why I would never be in business. My God, I don't know. I'm so not interested in that. But if you're interested in that, great. It's really neat. There's a lot of cool math. Oh my God. Okay. Oh, got a chat. Yeah, you don't want me doing your finances. That's for damn sure. Thankfully, my taxes are pretty straightforward. Okay. Number 3 is a algebra question. Oops. Yeah, exactly. I agree. Number 3 is an algebra question. Remember, I think we did one before. If I give you a slope and I give you a point, you can find the equation of the line like this. Yes? Is everybody with me? Right? I would just plug in the y piece here. I'd plug in the slope here, and I'd plug in the x piece here, and then I can clean it. Easy peasy. Yes? Easy shit. That's algebra. Why is this the same kind of question? Number 3 is the exact same question. Did I give you a slope? Did I give you a slope? Did I give you a value for m?
Yes, -1.
Yes, the slope is -1. Did I give you a point that my tangent line goes through?
3 or 5.
I gave you a point. 3, 5. So now you can just plug and chug, right? What goes here? Y minus what?
5.
5, because that's the y piece. Y minus the y piece equals slope times x minus
3.
The x piece, 11. Please let that be simple. That is just so simple, right? So y minus 5 equals negative x plus 3. So y equals negative x plus 8. Shlabam. Okay. Easy, 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 easy. Okay. What time we got? Oh, geez. Okay, we're going to do it. We're going to make it. We're going to make it. Let me do this. Let me do this. If I do this, can you guys, oh shit. Jeff, no, you're not where you're supposed to be. Dadgummit, where am I? Okay, hold on. Do. Okay, hold on. I want to get to 2.8. Where am I at? I think I'm still in 2.7. Hold on, everybody. Can you guys all see the book, by the way?
Yeah.
Yes, no?
Yes.
Okay, thank you. Here's where I want to be. Okay, now okay, listen, everybody. This is why it's so nice we're going back on campus soon, because this is some weird shit. It's much easier if we're together, but too bad. What I'm about to do is one of the hardest skills to get early in the calculus game. Your brain will balk. Your brain is going to rebel a little bit at this. So what I'm going to do, I want to graph on top of this. I'm going to graph what f prime would look like. Do you agree with me that every point on this graph has a slope associated with it? Every point has a tangent line. Does everybody agree?
Yes.
Okay, so let's start this. Let's see how this works. You could do this, Jeff. Where's your, I don't know. It's all right, Jeff. You'll be fine. Yeah. All right. So let's say at this point, can somebody tell me anything about the slope at that point?
It's positive.
It's big time positive, right? Big time positive. Jeff, so if I was going to graph, so I'm going to graph f prime here in blue. If I'm going to graph f prime, what it's supposed to do then is it's supposed to tell me the slope of f at every point. So isn't this slope here big positive? So at this position, whatever this is, the slope is big time positive. It's up there. What's the slope right here?
Zero.
What's the slope? Sorry?
0.
0. Yes, everybody agree with me? Is there another place where it's 0?
On the other side. Yeah.
Right here,
that
yes.
point- Yeah.
All right, so when you have to do this kind of problem, it's really smart to start with what I call anchor points. The easiest points to get are where it flattens out. In blue, I am plotting the slope. So where am I going to plot in blue? Here, right there, because it's 0 right here. Yes? The slope is 0 right there. Now, can somebody tell me something about the slope here compared to here? What's happening as I move along this? What's happening to the slope?
It's closer to 0.
Yes, it's getting smaller. Yes, the slope, it's kind of starting to flatten out a bit. And as I move along this, it's just going to keep getting flatter and flatter until it's really flat. So what is this graph of f prime going to do? Oh, shit, Jeff. Here we go, buddy. Here we go. Oh, crap and a half. Hold on, everybody. Oh, this is going to be gross. All right. Sorry. This is why I should be doing this on the board probably. Well, I can't do this on the board, so I'll give myself a, okay. All right, are you going to be able to do this? No, you're not. All right, I'm sorry. This is just so weird. Hold on. I really despise this. All right, I'm going to do it. I'm going to do it. So it's going to go like this. Oh, God, why is this so hard? Why is this so hard? There we go. All right. Oh, thank God. Okay. What's it do after this point? What's the slope become like right here? What's true about the slope right here?
It's negative.
It's negative. So doesn't this go through?
Yes.
Isn't it negative all the way through here?
Yes.
Until it gets to here. And let me ask you this. Let's see if you guys think this is a weird question. Is there a place? Oh, that's all right, Jeff. You're fine. Is there a place between the two zeros here where the slope is most negative. Can you guys see a place where the slope is most negative? Isn't it not that negative here? It's not very negative here, right?
Mhm.
Isn't it getting more negative?
Yeah.
But isn't it starting to get less negative over here?
Yeah.
Where is it most negative?
Would
Zero?
it be at the
Zero.
zero?
Yeah.
Does everybody agree? Right
Sorry.
here seems to be where it kind of starts to turn around. It's going, oh shit, and then it's turning around, right? So if this was like our profits, we're really interested in when, okay, it's going down, but it's going down less. So that's at least, you know, one good thing. We're losing money, but not as much. Okay. So right there should be where this has a vertex. Oh crap, make that big. Does that make sense? And again, each step, this is a little negative. This is a little more negative. Do you see why the points are getting more and more negative until they get to right here, and then it starts to get less negative, unless it's starting to turn back around until it gets to zero slope here. And what happens after this point? What's the slope forever after that?
Positive.
Positive. And getting more and more positive, right? And here's a little side note for anybody who's had calculus before. The original function, can somebody give me an idea of roughly what the original function equation needs to kind of include here? Well, the original function, what kind of function is it? Does anyone know?
X cubed.
So f of x has got to be somehow related to x cubed. Now, the fact that it's got the wibble wobble and shit, and it's not like a perfect little legless giraffe. I don't know if you guys ever heard. A friend of mine calls a cubic function a giraffe function. And I always joke them because it's like a giraffe that's missing its front leg. That's horrible. I say, Corey, somebody cut that giraffe's leg off. That's horrible, Corey. What are you doing? Anyway, sorry. But that works. Sorry. Stay with me now. I'm sorry. So this is roughly related to x cubed, correct? What happened? What is this definitely related to? Our result in f prime?
Where?
X
Or-
squared.
yeah.
Yes. So if anybody's had any calculus before, you know that this is starting to get into shortcuts for derivatives and how polynomials are easy to take derivatives of. We're not there yet. Okay. Oh my God. All right. So, sorry. This is cool shit, but it's such foundational stuff, and this is one of the hardest things to get down. So let me come back to this worksheet thing. It's going to be so much easier once we're back on campus, but you know, it's going to happen. Okay, so if you've still got that worksheet up, it's on the other side now. Oops, where are you, worksheet? Hold on, guys. There it is. Okay. So I have given us graphs. This first one shouldn't be too evil. It's basically the same thing we just did, right? Can you give a rough sketch of what f prime would look like for each of these things? Right? Okay, so go ahead and get a little ahead of me and then I'll catch up. So you don't have to print this out. It would be easier if you printed it out, but you can kind of do this on your own paper, right? Oof. All right, let me come in here now. Where are you starting on number one? The first one. We'll call it A.
Starting by pointing down the anchor points.
Anchor points. So it looks to be flat, like right there, right? So I'll put a point here, and it looks to be flat, like right here. So I'll put a point there. That's a great place to, and I really want you to get this. In blue, I am putting points that represent the value of the slope at that X position, right? So that's why I put a blue point here, because the value of the slope at that X position is 0. So where am I going to put a point like for -6? What's true about the slope at -6?
It's a
Positive.
positive slope.
It's big positive, right? And to be really honest, I let me see if you guys, this could be too much. All right, I'm just going to do this. Do you guys see how the slope here is roughly, let's see if you guys get this. Don't I go up 7 over 1 to get to this position here? And that's just an approximation because that's like really far away, but that's, you could get this more precise. I don't necessarily request that you get this so precise, but the slope at this point does seem to be around 7, because if I go up 7 over 1, I get to kind of like the next position. And of course, as I move along this, what's happening to the slope, it is progressively getting
Smaller.
say again.
Oh, the slope is getting smaller to the point where it's just 0.
I like it. So that means it's going to do something like this. Oh, Jeff, what is going on, dude? Are you feeling okay? Come on, you could do this. You could do it. You could do it. You could do it. All right, there it is. There it is. So it's going, oh boy. All right, there. Rah. All right. Oh, geez, I love this. And then what happens after the 0 point? What happens to the slope?
Crosses the x-axis.
And it becomes
Negative.
negative. The slope becomes negative. And is there a most negative position? Like if you had to kind of guess here, I would guess it happens in here somewhere.
2.
Maybe 0, right? I know what you mean, like here, but maybe 0 it happens or so. So then it's going to have like a vertex around there somewhere, and then come back up to here. Because it now, once you get past that point, it's starting to get less and less negative until it's 0. And of course, after that, it gets more and more positive. So up it goes. Okay. So again, we see a cubic become like a parabolic. The degree goes down by 1. Interesting. We'll have to prove later that that's a true statement, but we don't know that yet. It just looks to be so far. Part B is possibly freaky, hopefully easy. Why should part B be easier than part A? Is part B truly a curve? Is the slope here different than the slope here, different than the slope here? Are those slopes different?
No, it's a constant slope. So
Yeah, and what's the slope?
1.
Yeah, well, be careful. Down 1 over 1, right? Down 1
Okay,
over.
-1, yeah.
So all I'm going to do is this. I really want you guys to get this. Everywhere, the slope here is -1. So I'm going to plot -1. The slope is -1 everywhere. Now look, I'm going to stop right there for a second. I'm just going to stop right there for a second. What about the other side?
+1.
Sorry, I'm sorry.
Oh, +1.
+1. Okay. So every position I'm going to graph +1. Now what happens right at the origin?
0.
No, it isn't. It isn't 0. There is no slope at 0. Because all right. Let me do this. All right. Hold on to this thought. Okay. Everybody just hang on. I got something cool to show you. Oh, where are you? Hold on, everybody. Just hold on to your butts. I could do this on Desmos. Let's do this on Desmos. Sorry. Let's see if this works out pretty well. I think so. No, Jeff. Dadgummit. No, stop it. What are you doing? Go away. All right. I hate when you open something you didn't want to. Okay. Here we go. Desmos kicks ass. So if I do x squared, not to the 32nd power, Jeff. No. Jiminy Jeebus. X squared. Okay. Watch this. If I zoom in, what is happening? As I zoom in, what is happening to the curve of the parabola? As I zoom in, what is happening to the curve?
It's flattening out.
Remember what I said about flat earthers and all that shit, right? So here's the Earth. Not really. Earth's not parabolic, but so look at me. What's it becoming? As I zoom in really close to zero, isn't it a freaking straight line? Yes. Isn't it a straight line? That's what it means for a derivative to exist somewhere. It has to be locally linear. Let me say that again. Does that phrase make sense? This is locally linear. If I zoom in at zero, it is a freaking straight line. Yes. And this, of course, is an illustration of what flat earthers have trouble with. Now, if you're a flat earther, then stop. Anyway, now let's look at absolute value of x. See if the same thing happens. Do I just do that? I think I do. All right. I got to chat. Damn it. Let's see. Too political. Oh, oh, that's funny. If you weren't joking, I'd be like, yes, please do. Now, what's happening as I zoom in? What's happening as I zoom in? What's happening? Is anything happening?
Okay.
I am zooming in like stupid amounts. I'm gonna see the limits of Desmos here. Does everybody understand what's happening? I am stupid zoomed in right now. I am crazy zoomed in. Has it changed at all?
Nope.
No. Can you figure out why would a tangent line here be flat? There's no reason for it to be flat. It doesn't follow the curve because there is no curve there. So we call this a kink. We call this a kink, right? Like a kink in a hose. It's a sudden change. It is not differentiable at a kink because think about it like this. How is a function continuous? What has to be true for a function to be continuous at a point? Oh shit. What has to be true for a function to be continuous at a point?
F of x has to equal the limit of f of x.
Yes, the limit as x approaches that value has to be the same as the function value there, right? Now, for something to be differentiable, the derivative has to be continuous. Wasn't the derivative -1 here? And then it becomes +1 instantaneously. Is that continuous? In fact, let's come back to this picture. The blue line we just drew, is it continuous at 0? Nope. So it's not differentiable at 0. Okay. So here's one reason why I spent so much time on this. Where's a definite place that this function here is not differentiable?
-2.
Yes. So that it's, I was going to say it's kinky. It's a kink right there. I'm not going to judge this function, right? It's a poor function. Got to let it have its thing. There's what do they call it in the book? They don't call it a kink. I can't remember what they call it. Where else do you think this thing might have? Where's another kink? Does anybody ever? Do you guys see another kink? It's not quite as pronounced.
1.
Yeah. So there's a kink there. So it won't be differentiable there because the derivatives on both sides don't match up. And where's another place that it seems certain that it will have a problem?
X equals 3.
At 3, yeah. So if the function itself is discontinuous somewhere, it's not differentiable there. But also, if the derivative is not continuous, it's not differentiable there. Crazy. Okay. Forgot to mute my email. Okay. One last thing. By the way, all this right now is from section 2.8, right? And then we have, well, one last thing on this worksheet. And then we have one last thing for lecture today. And we're going to do this all right. Read the instructions for number 2. How is this different than what we did up here on the first part of number 1? Why are there 2 2s, Jeff? Jeff, your most basic job is to know numbers. Okay. Make that number 3. How is number 3 different from number 1? What does this represent? This graph.
Oh,
G prime. This is the graph of the slope. Yes? All right, this really gets weird. Here's something I need you to understand. If I tell you the slope of a line is 2, is that enough to graph it? If I tell you I've got a line in mind and the slope is 2, can you graph the exact line I'm thinking about? Because this line has a slope of 2, correct? But so does this line, and 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 so does that, right? You guys, are you with me? If I just tell you the slope, do you know where it's supposed to be? No. So this is why I say sketch a possible function. Because what is the slope of this function? What is the slope of g in here between -5 and -2? What's the slope supposed to be? 3, right? So I know the slope is 3 through that whole region. I can pick anywhere to put this. So I'm going to put it, this is weird. I can pick anywhere, just like look at what's the slope of every single one of these lines. Isn't it 2? If I told you to graph a line with slope 2, could you graph any of these and be correct? All of these would be a correct answer. So I'm going to start anywhere I want to. So I'm just going to randomly pick down here. So I got room to do a slope of 3, right? So I'm going to start here. Where do I go from there? I go up 3 over 2. Over 2, Jeff. I love you, dude. Up 3 over 1. Doesn't this have a slope of 3? Oh, crap and a half. Pretend like that's... No, Jeff. I'm sorry, guys. I absolutely cannot draw this dumb thing. All right. Let's see what I can do here. Oh, I forgot. No, I can't do that here. Sorry. That's something else. There's something I could use to help me, but not on this thing. Okay, there. Okay. And then I just go up 3, 1, 2, 3 over 1 again. Because it still has a slope of 3 here, yes? And then I still have a slope of 3 here. Up 3 over 1. I just happen to go there. Shaboo! Now what happens next? What happens here? What's the slope now?
0.
0. And what's a 0 slope line mean? It just has to be flat. Yes. So I can just do this. Okay. And then what takes over? What's the slope now between 1 and 3?
-2.
-2. So now I can go starting, and it doesn't matter these are connected actually, but I'm just going to make them connected. Go down 2 over 1, down 2 over 1. There we go. So now I got a -2 slope right where I'm supposed to. And now after that, what's the slope from 3 to 4?
1.
1. So now I just got to go up 1 over 1. Shlabang. Shlabang. All right. Pretty freakadelic. What time we got, Jeff? Okay. We can do this. This one's a little bit freakier. Let's see. What's a good way to do this? Let's start up here. Now this is weirder. This is much harder Because is the slope constant between -5 and -1? Is the slope constant? What's the slope at -5? And don't forget, this is a graph of G prime. So the black line tells me the slope. So what's the slope at -5? Where is the black line at -5?
1.
1. The output for the black line is the slope. Isn't the black line G prime? Isn't that what I said here? The graph that I give you is G prime. G prime represents the slope. So when I say what's the slope at 5, it's obviously 1 because that's where G prime is. G prime is the slope. So if I start here, I've got to start going up. But what's the slope at -3?
0
And then what's the slope do after -3?
goes to -1.
Goes to negative. So what I'm going to do is something like this. I'm going to have a flat part at -3 because it's got to be flat slope. And then by the time I get back to -1, I could be, oh crap and a half, back down here. So the slope is positive here, positive, but getting smaller. It's 0 at 3, and then it's negative, getting more negative. What happens at -1? What's the slope now from -1 to 2? Is it going to be a curve or what? What's the slope between -1 and 2?
Linear. So like
What's the slope? Exactly.
-1.
-1. So now I can go from this point here, down 1 over 1, down 1 over 1, down 1 over 1. Because the slope is constant. The slope is constantly -1 between those two. And then what happens from 2 to 5? What happens here? Let me not draw that. That looks like it's part of the answer. From 2 to 5. Isn't it going to be a lot like the first part again?
Yes.
So from 2 to 5 now, it's still negative, but then right here it's 0. It's 0 at 3. Is everybody cool with that? See how the slope is 0 at 3? So I've got to have like it's still negative here, and then it's 0, and then it starts to become positive, and then I can maybe go up to there or something. Who knows? Okay, that's good enough. That is weird shit. Yes, you have got. Trust me. Trust me. If you're doing number 3 or number 1, you have constantly got to be telling yourself what you are doing. Because the mistake I see people make is they just start to follow the function, which is not necessarily the answer. Okay, we got one last thing to do, and I'm going to try to remember what that is. Does anybody have questions from what we just did? Is anybody like, oh my God? Or probably. No, you guys are okay. Okay. All right, Jeff. You had one more thing you were going to do. What was it? You can do it. You can do it. Oh, Jeebus. Oh, that's right. Okay, I got it. All right, let me clear this from earlier. Now, so remember this function we had earlier, and we figured out the slope. What was it at? Oh, geez, I can't remember. Was it 2? Yeah, it was 2. Remember that we did that earlier, right? What if, so the way we did it was we said f prime at 2 is the limit as h goes to 0 of f of, I think it doesn't matter, 2 plus h minus f of 2 over h. What if I then had to find the slope at 3? I'd have to redo this whole thing with a 3 in there, right? What if I then wanted the slope at 4? I'd have to redo this whole thing with the 4 there. What if I then wanted, oh my God. So how do I, instead of figuring out the slope at a specific point, can I just figure out the slope at every point in one go? Can I do that? Wouldn't that be great? No? Let me ask you one thing. Is the slope of this function a number? Is the slope of this function a number? I know that's strange. Like, is the slope of this function a number? Yes. Why? Because it doesn't change. So it's constant. Is the slope here constant? No. So when I say find the slope of this entire thing, the answer will not be a number because it is constantly changing. Isn't the slope here different than the slope here? Right?
Yes.
Is the slope here is negative, slope here is positive, slope here is 0, slope here is more positive, slope here is more negative, right? So don't I want the thing that represents the slope, don't I want it to be a function of x? So I can then just put in, I want the slope at 2. Well, then put a 2 in. I want the slope at 3. So then put a 3 in. The slope isn't constant, therefore it must be a function. Isn't the slope changing depending on where I am? Isn't that exactly what a function does? Is it lets you put values in to figure out what it is at that point? So what we're going to do, instead of doing this, all we do is this. I want a function that represents the slope of f at any point. So I don't put a specific number in. Oh, Jeebus, what is happening there, Pen? Oh, Pen, you're doing some weird shit. Hold on, everybody. Oh, I see. Rawr. I just don't put a 2 in. I just put an x in. Okay. Just to make this a little bit easier to look at, hold on. Let me do one thing. Can you take the 4.9 out of there just for a minute? Let's pretend like my function is this, okay? Okay. Just because we don't have much time left, I don't want to go crazy. Okay, we have very little time left. So how do I do this? Well, so 2, 7 will be stuff like this. They want you to find the slope at a point. So you can just start off with the thing. 2, 8 then says, why don't we just make a slope function? So then whatever point you want to know the slope, you can just plug it into that function once instead of doing this each time. That would suck. So what is f of x plus h? Don't I need that? I need that for right here, don't I? So f of x plus h would be x plus h squared. So it'd be x squared plus 2xh plus h squared. Is that cool? So if I put that in, x squared plus 2xh plus h squared. And what is f of x?
It's x squared.
X squared. So then what cancels?
X squared.
The x squares cancel. And what is the limit as h goes to 0? So now I can cancel an h out from each of these, yes? So I get 2x plus h. And if you let h go to 0, what is that?
2x.
Holy shit. Now again, some of you who have had calculus, you're like, well, yeah, duh, you just bring the 2 down. You can memorize that shit, but you better understand why it works. This is why that is true. So then let me ask you, what is f prime of negative 1? Can you figure that out quickly now? What is this again? This is f prime of x. So what is f prime of negative 1?
-2.
Negative 2. What is f prime of 0?
0.
0, exactly what we knew. Isn't it flat here? What is f prime of 1? 2. Okay. Much better than doing it for each frickin' point, right? Let's just go ahead and get a function that represents the slope at every point. So this is the idea behind section 2.8. They just kind of expand on 2.7. It's like 2.7, that's cute. Let's just do it for every damn point, right? Okay, maybe you guys are with me, I don't know. Just, it's really easy to forget that right here, this is just y2 minus y1 over x2 minus x. That is all that is. That is all that is, yes? It is so easy to forget that that is what that is. You guys, anybody not believe me? It's okay if you don't believe me. Doesn't mean you think I'm wrong. You just don't think you just don't believe what I'm saying. So last thing, let me just remind you what's going on here. What color are you not use? Green. So what are the, so if I'm given a function, I have x and x plus h, right? And then of course I have f of x plus h, and I have f of x. So don't I have the points x, f of x, and x plus h? Oh, Jeebus, Jeff, can you do this? Hold on. Hold on to your butts. Here we go. X plus h, f of x plus h. If I do this, don't I get f of x plus h minus f of x? That's y2 minus y1, y2 minus y1 over x2 minus x1. What is x plus h minus x?
H.
H. So this is just algebra. That's all that is. That is y2 minus y1 over x2 minus x1. And then when I do this, it becomes calculus. It's kind of crazy. Okay. I think that's enough. What do you guys think? All right, last, I'm sorry. I forgot to say this earlier. I'm going to shut this down. You ready? I'm going to stop sharing. Here it goes. So just to show you, the quiz is going to work the same way the first quiz did. It's actually open now. So if you go to modules, you'll see quizzes here. Here's quiz 2. And you can start it now. What I've done is the minute you start, you have an hour. But you can start anywhere up until tomorrow at 1, I would say, right? Give yourself a full hour. So you find an hour of time between now and tomorrow at 1 and take the quiz. Right? If something happens and you have a problem finding time, let me know. Right? Let me know. I can work with you individually. But in general, I don't want to give too much time for the quiz and all that stuff. Okay.
Wait, so do you mean now and tomorrow or now and Friday? Because it said Friday.
What did it say? I'm sorry.
It said Friday at 2 p.m.
Oh, let me look at it here. Sounds like something I would do. No, here, let me show you again. Due February 17th. That's tomorrow.
Shit, that's my bad.
No, it's all right. That's all right. You got, yeah, please stay on me because I that sounds like a mistake I would make. In fact, I think I already made that mistake once. Yay, Jeff. All right, guys. So you're free to go. Don't forget the quiz. You can hang out if you got questions. And don't forget I have office hours at 11:30 also on Zoom. Cool. Bye, guys.
Thank you.
You're welcome. You guys all right out there? Okay. You guys, I don't know. All right. Tyler and Thomas, I got you, man. You should really be in class. It's all right. Bye.